Number 47. Write the balanced nuclear equation for the production of the following transuranium elements. And in this case, we have fermium-254, which is made by the reaction of plutonium-239 with a large number of neutrons. How many? 20? 30? A large number, but we'll see. Now, in this case, we just have to write a balanced nuclear equation, right, for what's going on here. Now, they're saying that fermium-254 was made by this reaction, right? So if you're making something, that means that fermium has got to be in the products. And the reaction has to be plutonium, Pu-239 with a ton of neutrons. That's going to be in our reactants. So let's see if we could plan this out. Now, we're dealing with the nuclear equation. That means that we need nuclei notation, which means that you have three different stuff going on, right? You need the element symbol, the mass number, and the atomic number. I like to write them in cute little boxes like this. So let's start off with saying, okay, we have Pu, right, plutonium, Pu-239, and that is going to react with a lot of neutrons, right? So maybe we'll just put, neutrons here. And we are going to get out the fermium. So we have another one like this, and that's fermium. Now, let's write in all the stuff that we can for right now. So I guess let's start off with plutonium-239, right? Plutonium Pu, that's the symbol, and the symbol always goes in the blue box. So Pu. 239, right? That is always going to be your mass number. Now they have to tell you the mass number because mass numbers can change for the same elements because you can have different number of neutrons. So different number of neutrons gives you different mass numbers because the neutrons are in the masses. And the mass number always goes on the top. So in this case, plutonium has a mass number of 239. Now, they didn't tell us what this yellow thing was, right? So this, the yellow, right, that's your atomic number. Atomic number. And the atomic number is special because atomic numbers don't change per element. That's why they didn't give it to you, because they assume that you have your periodic tables right in front of you, and you're going to look and see what the atomic number for plutonium is. Now, I have my periodic table in front of me. I'm going to look to see where Pu is. And Pu has lucky number 94. Atomic numbers are always those beautiful whole numbers. It's not the decimals. It's the whole numbers. And each whole number is for a specific element. Okay, so we got that going on here. Now, let's add in our neutron. A neutron is a subatomic particle, and it has lowercase n for neutron. Now, just know that neutrons, their atomic number, right, the number of protons, it's not a proton, so it's got nothing to do with protons, so it has 0 as the atomic number. But neutrons are in the nucleus, and the nucleus is the mass number. So 1 neutron stands for 1 mass number, right? The 1 stands for, hey, I got 1 neutron. This is always the symbol, and I'm just going to keep writing 1 until I'm very satisfied with how the 1 came out, and I think I'm stuck in a loop here. Help me. Okay. No, I'm really stuck. Okay, here we go. Thank you, guys. Thank you for pulling me out of it. So just know that neutrons, right, is always lowercase n and a top number 1 and a 0. Always. Now, they did say that we had a large number. So maybe I have 2 neutrons, I have 3, 4, I don't know right now, but just know that if I do have a, X amount, that's going to be the coefficient in the front. So maybe I'll have 2 neutrons. Maybe I'll have 3 neutrons. That's how you write that you have multiple of these. You put a big number in the front to say, hey, I got, 4 of these or 5 of these or whatever. But let's keep moving on for now. Let's fill in what the fermium is, right? Fermium on the periodic table, I spotted out. It's Fm, They're telling us that fermium has a mass number of 254. So 254 is on the top. And I look on the periodic table to see what the mass, what the atomic number is for fermium, and fermium is always 100. Okay, now let's see. Are we balanced? Well, we have 2 39s plus 1, so that's right off the bat, that's a 40, right? 239 plus 1 is 40. That doesn't equal 254. I need to jack this number up to get it to 254. Now let's just say if I put a 2 in front of here, right? How many neutrons would I have? I have 2 of them. And 2 times 1 would tell me that I have 2. So if I say 239 plus 2, that's 241. That's still not 254. So what we're going to do is maybe we have to use a little bit of algebra. I don't know what number this is, but whatever number it is, I know that it's going to be multiplied by 1. So we could just do a little bit of algebra, right? 239 plus x equals, you could use the yield sign as an equal sign, and I want it to get to be 254. So if I do subtract my 239, and I calculate that, let me just throw this somewhere else. Maybe we'll throw it down here. I guess that's good enough. Right, 254, whatever that is, that's a 1, 240, 1 is 250 for 10, so 15. There you go. So 254 minus 239 is a whopping 15. So that means that you should have 15 neutrons to get you to the 254. So what X value do you think we're going to put up there? Yeah, you're right. A 15. That's a large number. But now let's see. Right? It gets rid of this, right? 239 plus 15 is 254. But now let's look at the atomic numbers. 94 plus 15 times 0 is 15. Christina, geez. 15 times 0 is 0. So 94 does not equal 100. Now it seems like this is the reaction, so I can't add anything to the reactant side. But I could pick up the slack by adding subatomic particles on my product side. So let's see what subatomic particle I'm going to add. Now, we already, did well with making the mass numbers the same on both sides. Keep in mind that this was now equal to 254, which is right here. So how much more would I have to add? I want to keep it 254, so I'm going to have to add 0. But now here, 94, 15 times 0 is just 0. So 94 equals 100 plus x. What number would this be? Yeah, if I subtract from 100, it's going to be a -6. However, 0 on the top, -6 on the bottom. What subatomic particle is that? Nothing that I know. So I have to think of a subatomic particle that at least has a 0 on the top and a negative value on the bottom. Do you know which subatomic particle that is? Did you say electron? If you did, you are absolutely correct. An electron is the same thing as a beta particle. So whether you want to say B for beta or E for electron is fine with me. Usually I like the B, right? But an electron or a beta particle only has a -1 because you're only talking about one of them. So this we're going to have to use, oh boy, I'm stuck in the loop again, guys. Okay, that's fine. But we definitely need to have multiple of these. Remember, the number was -6. So what times 1 will get me -6? Yeah, you're absolutely correct. I need 6 of these. So a big 6, a whopping 6 in the front. And now, everything will be balanced. And this is the final answer. What'd you think? I hope this helped. Thank you so much for viewing the video. Subscribe to the channel, like the video. Just helps get the word out there that this educational channel exists. We have physics videos, we got math videos. This channel is just my brother and I. We had, we made it during, that special time in 2020 where everybody was home, and we decided we really wanted to help you guys, so we just started doing these videos, and it's become what it is today, and that's all because of you guys. So I'm so excited that this channel can help you guys out in your classes. Thank you so much for all your kind comments. I really do read every one of them, and I try to get back to as many as I can in my free time. So yeah, thank you so much. We also opened up memberships for this school year. If you guys want to become a member to the channel and help the channel out a little bit more, you can. There's 4 different tiers. Maybe one will suit your fancy. Thank you for considering. Obviously, it's not, obligated, but anything helps. Thank you. And I hope you have a great day. Always, I hope you have a great day. And I'll talk to you soon, okay? All right, bye-bye.